Welcome to qnawire.
All right, we're doing a half-life problem, and we know the half-life of a substance is 15 hours, and we know we start with 2 grams. And so when 15 hours elapses, there's now 1 gram, half of what was started with. Another 15 hours goes by, and there's half of it. Another 15 hours, another half. And then finally, when we get to 60 hours, which is what we're interested in for this problem, we're down to 1/8 of a gram. So the answer to part A is when 60 hours have elapsed, there's 1/8 of a gram left. Okay, the next thing we want to do is figure out kind of a generalization so that we can know how many grams are remaining after T hours. So looking at the pattern we've seen so far, notice that we have started with 2, and then we multiplied it by 1/2, we multiplied it by 1/2 again, 1/2 again, and 1/2 again. So the exponent on 1/2 keeps increasing. And how does that exponent relate to the number of hours that have elapsed? So if you take the number of hours and divide it by the half-life, 60 divided by 15, you get 4. The number of hours divided by the half-life, 45 divided by 15, you get 3, etc. So we can generalize this. And so if T hours have elapsed, then we have the number of hours T divided by the half-life as our exponent. So this gives us our formula for the number of grams remaining after T hours. Now we can use that formula to figure out how many grams would be remaining after 4 days have gone by. So if 4 days have gone by, 96 hours have gone by, so we can use 96 in our formula and put that into the calculator, and we get 0.0237 grams. And lastly, we want to know how long it would take for the mass to be reduced to 0.01 grams, 1/100th of a gram. So we grab a calculator and we type our function in, 2 times 1/2 to the x over 15 power, and then we also type y equals 0.01. So that would be a horizontal line at a height of 0.01, and that represents that level of 1/100th of a gram remaining. For my window, I fiddled with the numbers for a while until I came up with a good view of everything. I chose to go from -1 to 150 on my x-axis and -0.1 to 0.5 on my y-axis. And those numbers can vary. You just want to be able to see both your exponential decay graph as well as your horizontal line, and you want to be able to see the intersection point. So now let's find that intersection point. So we can go into the Calculate menu and choose number 5, Intersect. We have the cursor on the first curve, so we press Enter. We have the cursor on the second curve, so we press Enter. And then we go over toward the intersection point and we press Enter. Now looking at the bottom of the screen, we can see that x equals 114.66 when y equals 0.01. So that tells us that it's going to take approximately 114.66 hours to get to this level.